Hello, this is Team 5 for the CW1B presentation for CO651 Quality Assurance and Testing. We are joined by Arbaaz and AK, who will be discussing tool support for testing and relevant information on this subject. This is Arbaaz speaking now. What is tool support? This refers to various test tools that assist the software tester in doing testing activities. These tools can be used to test code by executing it, manage requirements and test cases, perform code analysis, and more. Why do we use test tools? Because they can increase efficiency by executing tasks automatically, especially those that are repetitive or require significant resources such as retesting and performance testing. Improve the quality of test activities by allowing for more consistent testing and a higher level of defect reproducibility, and increase the reliability of testing by automating large data comparisons. When should test tools be used? Across all aspects of the software development lifecycle, requirements, design, development, testing, maintenance, there will be opportunities to use these tools. They help the software tester undertake functional and non-functional tests across various testing types such as unit testing, regression testing, and performance testing. What about manual testing? Manual testing is performed by testers step by step, whereas with automated testing, many test tools can execute tests automatically. Manual testing is still valuable for processes like exploratory testing, usability testing, ad hoc testing, and other test types. Who should use test tools? Organizations and developers that meet certain criteria would benefit from using them. If the test tools provide a time cost benefit than toolless manual testing, if the organization is mature enough and understands its objectives, if the tool is compatible with the codebase in question, and if there is support for the test tool, such as training or product support, these factors indicate that a test tool would be valuable to use. Test tool classifications. There are 6 main classifications for test tools. They are management tools, static testing tools, test specification tools, test execution and logging tools, performance and monitoring tools, and tool support for specific testing needs. Management tools apply to all test activities over the software lifecycle. Test management tools will interface with execution tools and requirement management tools. They can also support traceability of tests to source documents, and they would log test results and generate progress reports. An example of a test management tool is Moztrap. Requirements management tools will store requirements, check for consistency, enable traceability between requirements and test cases, and can prioritize requirements. An example of a requirements management tool is IBM DAWs. Incident management tools will store and manage incident reports describing defects and failures. They can prioritize defects and root causal analysis, assign action items and tasks to resources, and capture the status of an incident, open or closed. An example of an incident management tool is ServiceNow ITSM. Configuration management tools will keep track of different software versions, even across operating system and hardware versions, can build software, and enable traceability between documentation and software. An example of a configuration management tool is Ansible. Static testing tools allow detection of bugs and defects before code is run, such as white box testing. Review tools collect information about review processes, give information on defects and efforts, and handle references to review rules or checklists. An example review tool is Crucible. Static analysis tools enforce coding standards, analyze code structure, and calculate the complexity of code. An example static analysis tool is ReSharper. Test specification tools regarding the test design and implementation generate tests and prepare data. Model-based testing tools validate a model, check defects and inconsistencies, generate test cases based on the model, and allow early detection of defects. An example modeling tool is GraphWalker. Test data preparation tools manipulate databases, files, and data transmissions, mask live data, and prepare bulk data for performance testing. An example of a test data preparation tool is Generate Data. I'll leave the rest to AK.
This is now AK speaking. Test execution and logging tools run tests and provide frameworks. Here are 4 tools within the test execution and logging. Test execution tools are software applications that assist in the setup, running, and management of testing during the software testing phase. They are essential for efficiently managing the test process, especially in environments with extensive test suites or where continuous integration and deployment practices are in place. Test harness tools are a collection of software and test data configured to test a program unit by running it under varying conditions and monitoring its behavior and outputs. Test harness tools are essential to software testing, providing an automated framework that facilitates the running of detailed test cases. They often include both the testing infrastructure and the specific test cases and configuration necessary to apply the testing methodology. Coverage management tools in testing are designed to measure and report on various aspects of how thoroughly the software has been tested. This coverage typically refers to code coverage, which indicates the percentage of source code executed during testing, helping to identify untested parts of a code base. Coverage management tools are essential for ensuring high-quality software development by identifying gaps in testing and providing data to guide further testing efforts. Security tools are specialized utilities designed to identify, analyze, and help mitigate vulnerabilities within an application's code, dependencies, or runtime. These tools are crucial in developing secure software, ensuring applications are protected against common security threats and adhere to best practices for cybersecurity. Performance and monitoring observe systems behavior. There are two tools within performance and monitoring. These are dynamic analysis tools, performance and testing tools. Dynamic analysis tools are critical components in the software development and testing process, focusing on evaluating the behavior of a program while it is running. Unlike static analysis tools which examine code without executing it, dynamic analysis tools require the applications to be in a running state to observe its behavior under various conditions. These tools are invaluable for detecting issues that only manifest during the execution of the software, such as memory leaks, concurrency issues, and other runtime errors. Performance testing tools are specialized software applications used to determine how a system performs in terms of responsiveness and stability under a particular workload. These tools are essential for identifying potential bottlenecks and ensuring that software applications can handle expected traffic and processing loads before being released to production. The focus is primarily on measuring critical performance metrics such as response time, throughput, reliability, and resource usage. These two test tools have already been discussed but are shown here as they have specific testing needs. Special consideration for test tools. When selecting and implementing test tools from software development and testing processes, there are several special considerations to keep in mind to ensure that the tools are effective, integrate well with other systems, and provide the necessary support for your testing requirements. By carefully considering these factors, you can select a test tool that not only fits your current needs, but also supports your long-term quality assurance and development strategies, ensuring software quality and effectiveness. Side effects. The adoption of testing tools in software development and quality assurance processes bring numerous benefits such as increased efficiency, improved accuracy, and better coverage. However, like any technology integration, there are potential side effects or unintended consequences that organizations should be aware of when deploying testing tools. The probe effect and Heisenbugs are two notable phenomena in the realm of software testing and debugging that can significantly impact the process and outcomes. Both are related to the unintended consequences that arise when testing and monitoring systems. Derived from the quantum mechanics terms Heisenberg uncertainty principle, a Heisenbug is a software bug that disappears or alters its behavior when one attempts to study it. This type of bug is often highly transient and can be caused by a variety of issues including race conditions, uninitialized memory, and timing issues. Heisenbugs are particularly troublesome because they make debugging and fixing the software quite challenging. Success factors for tool deployment. Successful deployment of software tools within an organization, particularly those used for software development and testing, require careful planning and execution. The ultimate goal is to ensure that the tools not only integrate seamlessly into existing workflows but also improve the efficiency, productivity, and the overall quality of outputs. By addressing the success factors, organizations can maximize the effectiveness of testing tools, leading to more robust software products and more efficient development cycles. These factors can help ensure that the tool not only fits the immediate needs but also contributes positively to the long-term software development and testing strategy. Now the following slides will be the questionnaire.